Hello. This lecture focuses on the blockchain technology as part and parcel of the information systems for logistics management. So we answer first, what does it do? What is it? What does it do? This blockchain creates a true peer-to-peer secure transaction. It has two main jobs. It would like to secure your data, meaning maintain trust, and record virtually everything of value. It is a recording system where you have multiple databases connected to one another, and whatever you record in one point is immediately moved or copied to all the other participants in that particular network. So let us compare that. Let me show you an example. In this particular case, using this without a blockchain, what happens is that a car, an asset, is transferred ownership. There are a number of participants in that particular process. First, initially, the manufacturer will be transferring the ownership to a dealer. In that particular case, the manufacturer has its own database, or what we refer to as a ledger. It records the car there. And then when there is a transfer already, that is removed from this ledger and transferred over here. And from there, when a leasing company, for example, budget car company, then that is moved here. So there's a leasing company, there's an in-house ledger, and from here, when you borrow this car, then you're the lessee, and then you have your own registry or recording system. You record it here, and so the business goes like this. And then towards the end, once it is finished, when the car is done, it is sent to the scrap merchant for final disposal. And the scrap merchant will have to record that also. All of this has to be monitored by a regulator, by a government agency, to make sure that that particular plate number and that particular serial number of that motor is moving properly from one owner to another until its final disposal. So they have each one has its own database, recording system, or a ledger, like this. When we move to a blockchain system, what happens is that there are various nodes. Each regulator would have its own computer with its own node, with its own recording system, as well as this one, the dealer, the leasing company, the lessee, and the merchant. And of course, the regulator is just there. What happens is that when things are moving like this, for example, a car is generated here, immediately that data is propagated already to all the participants. When that particular record is moved to a dealer, that is propagated to all the other participants in the network, like this. So even if a participant or in a particular transaction, for example, the dealer sells to a leasing company, actually this particular transaction is just a transaction between the dealer and the leasing company. But this particular transaction is broadcasted, in effect, to the regulator, to another manufacturer, to the scrap merchant, and to the lessee. So that's where maybe you will say, what happens to the security issue? But this is what we refer to as permissioned. Maybe it is recorded in your database, but you cannot see it if you are the lessee or if you have a scrap merchant. Not until you are allowed to see. But once you see it, for example, there is a car here. There is a car to be destroyed or put into a scrap. that particular car's history can be seen by this scrap merchant because he is now permissioned to see that particular record. He would know when it was first purchased, how many and who are the ones who borrowed that particular car, and finally, uh, when it is being turned over to the scrap. All of these transactions are also can be seen by the regulator. The regulator, as an auditor of the system, would have an overall view of the transaction because he's permissioned to see everything. With blockchain network participants can interact as follows. The regulator creates and populates the registration for the new article on the blockchain and transfers vehicle ownership to the manufacturer. The manufacturer adds the make, the model, the vehicle ID number to the vehicle template within the parameters allowed by the smart contract, a digital agreement or set of rules that govern a transaction. We have to go back here and study what is the smart contract. The smart contract here are like a trigger that are attached to the transaction, and whatever are indicated here, for example, this is the smart contract together with the shared ledger. Suppose it says here that the car is already 50 200,000 kilometer usage already. Assuming there is a part on that smart contract that which says that if it's already 200,000 kilometer, it will be automatically transferred to a scrap merchant. See, or also if the car is already being used by the leasing company or by a lessee for say 5 days, it has to be returned back to the leasing company for a renewal of contract. This is part and parcel of this. So we have of this smart contract. So we have to look at the smart contract as something that is inside the node, and that particular node is the one monitoring what's happening to this shared ledger, and the propagation of the data is coming from this shared ledger. But the smart contract can alter what is inside here because of a rule that is pre-approved by all of the participants in the network. And that's what is meant by the smart contract here. So the manufacturer adds the make, the model, the vehicle ID number to the vehicle template within the parameters allowed by the smart contract. And number 3, the dealer can see the new stock availability. Ownership of the vehicle can be transferred from the manufacturer to the dealership after a smart contract is executed to validate the sale. The leasing company can see the dealer's inventory. Ownership of the vehicle can be transferred from the dealer to the leasing company after a smart contract is executed to validate the transfer. The lessee can see the cars available for lease and complete any form required to execute the lease agreement. Alright? And finally, number 6, the leasing process continues between various lessees and the leasing company until the leasing company is ready to retire the vehicle. That point number 6 is this. It continues to go back and forth until it is now ready to be transferred to the scrap merchant. All of these are monitored by and recorded into a this particular database. And how does it do it? It does it in this form. Every player, every participant would have a block of data where the transactions are recorded here. Transaction number, and so on and so forth. And it is it connects to the next block, or for example, let's look at this. This particular block 1575 connects to the next block, and it connects to the previous block. So this particular sequence knows that a particular car was borrowed by a person ABC, and it is now being borrowed by DEF, GHI. So you know the sequence because of this linkage. No need for a numbering system that you have to follow. And these are the key concepts of blockchain for business. Number one, there's a shared ledger. Shared ledger, we call it shared ledger, but actually it is a database where everyone has a complete copy, and the method of writing to that particular database is append only. You just add, keep adding and adding. Append only distributed system of records shared across business network. And number two, permissions. There are particular transactions that are allowed to be seen, and there are transactions that cannot be seen. So ensuring appropriate visibility, transactions are secured, authenticated, and verifiable. And number three, it is the smart contract. Business terms embedded in transaction database and executed with transactions and consensus. All parties agree to network verified transactions. This particular shared ledger, you can think about it this way now. If it is a database in one particular site, for example, budget car rental, and you say it is only append only. Append only means no erasure. Keeps adding and adding and adding and adding. In say 50 years, this transaction would be a lot, and you need now a huge computer, or you need now a computer farm to support this. That's why they are saying that this particular blockchain, if it is allowed to function in the same way we want to make use of it in business, then we probably need a similar database infrastructure similar to the internet. Just look at what Google is. Google copies or has a record of all our email for all of the people in this world. Do you imagine how many people are there with an emails in Google? They have it. They can do it. How do they do it? By distributed databases all over the world. And they protect this data like a bank. There's a security system where your email and my emails and everyone's emails are properly protected. That's why they charge money for these functions. And also we give them rights to read our email without violating our privacy. Same is true with this concept. If you allow the blockchain to flourish and to monitor, they say that this particular blockchain records assets. What is an asset? Asset is a building, a car, a person, a work of art, meaning paintings, and all of this. And it can monitor. The idea is for this particular work of art to be monitored in terms of its movement. Like the painting, for example. How do you know the authenticity of a particular painting, a work of art, and how it changes from the original painter to now? If you're going to monitor the ownership of a painting, it could be dated like 100, 200 years ago. And you want to have a record of that, moving from one person to another. And the method of writing into that, say, notebook, if you please, is like append only, write on, append only. You only can write. You can only add data there. You cannot, if there's an error, you can only do that by another correction. Okay, but there is no deletion. You cannot erase anything into that databases. So you just imagine how big it will be later on, and you think now how big it will be, the database supporting Google. And there are many ways of doing this. Like Microsoft has a computer farm. We can talk about big data, all of this hardware that supports all of these concepts. But anyway, I hope it's clear that this is shared ledger, and it is whatever is recorded in participant A, say participant Toyota, that is automatically also recorded in participant budget car rental, and also participant government, and all over the world if that is the case, especially if you allow a particular asset to move around the world, to be traded around the world. And let's look. Blockchain-based logistics. Blockchain has been being used for trucks, parking spaces, warehouses, because you can now identify now. For example, if you would like to rent out a warehouse space, then a warehouse space can be rented out and it is recorded. And the next guy who will rent the particular warehouse space would know who were the previous renters to this space, because of the transaction trace. And also the government authorities would be able to know who were your clients. And this would, and if your warehouse space is used for fraudulent activity, like you allow them to make use of your warehouse space for bad events, then you can be liable for that, and they would be able to trace all of these transactions. Parking spaces also, as well as the truck rentals, delivery services. Like, for example, you purchase a KFC package, fried chicken from, and a guy is coming over to your doorstep to deliver this food. You can now double check on the blockchain how long it took them to prepare this. And then furthermore, you can go through the blockchain continuously, where they purchase ketchup, where they purchase the chicken, at what time they purchase the chicken. Then you would know the freshness of that particular package. So we have delivery services. You accept delivery, and you can also offer delivery services to other people, and you can trace the transactions of your offerings. It in effect contribute to a society where data are available to most people who are permission to see. This blockchain technology is available right now. Many attempts are being done in the area of finance, power, healthcare, real estate, tourism, and so on and so forth. Education. For education, it could be a method to record your transcript of records, your credentials, your CV. Because what happens to a CV? When I am an employer, from HR, I receive your CV. I try to look the courses that you took, the teachers from whom you got this. The CV does not indicate this, who were your teacher, and the date, and also I will not be able to know the books that you use unless I go dig in. Furthermore, you might be getting extra courses, SAP from Fortman, all of this. Under the blockchain system, every time a teacher is finished with, say, with you, or after you are finished with a teacher, you get it recorded into your blockchain. So it piles up into your blockchain. And so, as a teacher, I would know who were my students this semester, yes, last semester, because of the blockchain, and it is easily maintained. I don't have to go to a central party. I don't have to go ask permission from the student registry to get your data, because I am permission to do so. Also, you, in that case, you can easily present your CV to an HR department, and that HR department doesn't have to call me. All he has to do is to look at the blockchain, and he would see this data, and he will believe what is there. He doesn't have to call YUC, because all of these are already trusted. The data there are trusted, and you know that the blockchain is moving. That's why they say that this blockchain will speed up processes, because there's the act of tracing back doesn't have to be done, because these records are being trusted already. Example, for stock market, just for stock market, because of blockchain, because of blockchain, a person, i- this is an actual case. No? London Stock Exchange test this out by selling in Italy. No? What happens is that imagine companies can register, issue, and trade shares on the blockchain platform. What does it mean to you? In brief, you can buy company shares using digital currency. So in effect, in Italy, um, a person, an Italian, can buy a small part of stocks that are listed in London Stock Exchange, and without being in London, he just buy it and then pay using Bitcoin, and he believes that this particular ownership is valid, is real, because it is done through the blockchain. Because the blockchain means he has a copy, or his agency has a copy of the data, as well as London Stock Exchange has a copy of stocks on the blockchain. And since these blockchain are being monitored like every second, then the trust is there. There is an online retailer called Overstock. It started to issue company shares via Bitcoin blockchain technology applications. What is a Bitcoin? A Bitcoin is an application built using blockchain. It is a form of currency where where a particular unit of Bitcoin is used to buy something. But we are not covering this Bitcoin here. We are just using the blockchain from the point of view of supply chain management. And you see, let me, before we move on here, we said earlier that these nodes are like being refreshed every time there is a being movement. Every time there are transactions recorded here, that refreshing, that re-recording of data, if there's something's happened here, it is recorded here, is is done by something like a newsboy. You know, a newsboy, somebody who moves around and bring news to all the customers around the neighborhood. That happens here. Whenever there's a data here, that data is updated here, like a newsboy. That newsboy is working at the speed of light. He moves like that, very fast. All right, and that newsboy is not like it's not slowing down in effect, and there's no deletion. He's always adding up data here. How do you implement this? There are two competing technologies now on how to implement this. One is the Hyperledger Fabric by IBM, and the other one is Ethereum. So if you're interested to do some more work on this area, you can go to Hyperledger Fabric or Ethereum. These are the two techniques in working out and realizing a small project. There are other technologies available, but these are the two major technologies now, and there are many more testing that are being done in test project on this area. And sometimes you will think that this blockchain is actually a replacement of a distributed databases, and maybe it is not that, it will not be like a primary technology. I'll give you an example. For example, SABB, as a banking system, they have a record of the balances and money transactions of each and every depositors. I'm one of them. You maybe many of you are one of them. And what happens is that every time I withdraw money, it is recorded in their database. Every time you withdraw money, it is recorded there. If you send money to somebody else, it is recorded in SABB, of course, because that's their central database. If I receive my salary, it is recorded there. If you receive your money from YUC, it is recorded there. When you replace, for example, suddenly one day, SABB changed its mind, it would like to do blockchain. That means you will have to put up your own laptop or maybe your own computer system. I will have to put up my own computer system as well as everyone. And each of us will have to record each one's transaction. Every time I withdraw money, so it's recorded in my computer, it's recorded in your computer as well, and it's recorded in SABB's computer as well. And it is also recorded in the central bank's computer as well. Because the central bank, or SAMA, Saudi Monetary Authority, is monitoring all of these transactions. And every time I receive my salary, you get to get a record of it, although you cannot see it because you are not permissioned. As well as if you receive money from YUC, it gets recorded in your computer and in my computer and SABB's computer. But we don't, SABB can see because he is permissioned to see it, but I cannot see. And even I'm not aware, but my computer is aware. It's like a virus inside my computer. In that case, it will continue to be filled up like that. So maybe it's better for in the setup in this way, the current system, where SABB maintains a huge computer and we just transact with it. Because not every depositor is willing to do this effort of putting up their own computer system. However, there are applications where it is better, maybe it's cheaper to do blockchain. Like for example, if you have multiple warehouses where you need to monitor the releases of items from one location to another, setting up a central warehouse would be harder. A central computer is harder to do that. It's easier to do a small blockchain system to monitor the release of an item. So every release in one location is known by the other. Like right now, this issue of being of putting up the resources, like in this COVID situation, COVID era in the US, where all the cities or the different states are banding together, being as a group, and trying to share resources. If they want to share resources, they will have to set up a recording system of how much items are being borrowed, how much items are being used, and what is the actual balance in one particular state. So they would know how much money and how much items are being used and how much do they need and how many else can be sent. And then they can trace back how much were lent out. So later on, when the good times come back, they can start to collect back and be paid for the resources that they provided. Okay, so this is our lecture on blockchain technology. I hope you learned a bit, and thank you for your attention.